Okay, welcome to day 13. They're about to post the problem, and so I'm about to try and solve the problem. So let us go visit my little thing, receiving your content. Your audience will see it in a moment. Get ready, you are live. Okay, and the problem seems to be available. Minecart madness. A crop of this size requires significant logistics to transport produce, soil, fertilizer, and so on. Elves are very busy pushing things around in carts on some kind of rudimentary system of track system. Seeing as how cart and track systems don't appear in recorded history, elves seem to be making this up as they go along. They have been figuring out how to avoid collisions. You map out the tracks, your puzzle input, see where you can help. Tracks consist of straight paths, curves, and intersections. Curves connect exactly two perpendicular pieces of track. For instance, this is a closed loop. Intersections occur when two perpendicular paths cross. Intersection of cart is capable of turning left, turning right, or continuing straight. Here are two loops connected by two intersections. Several carts are also on the tracks. Carts always face either up, down, left, or right. On your initial map, the track under each cart is a straight path matching the direction the cart is facing. Each time a cart has an option to turn. It turns left the first time, goes straight the second time, turns right the third time, and then repeats those directions, starting again with left the fourth time, straight the fifth time, and so on. This process is independent of the particular intersection at which the cart is arrived. That is, the cart, no per intersection memory. Carts all move at the same speed. They take turns moving a single step at a time. They do space in the current location. Carts in the top row move first. The carts in the second row move again from left to right. The carts in the third row, once each cart has moved one step, the process repeats. Each of these loops is called a tick. For instance, suppose there are two carts on a straight track. First, the top cart moves, is facing down. The down. Second, the bottom cart moves, facing up, so it moves up one square. So carts have moved. The first tick ends. Colliding with it, crashes X. Here's a longer example. Cart. Essentially crashed. Help from a crash using the location of the first crash. Locations are given XY coordinates where the furthest left column is X and the furthest top row is Y. Okay, this is all very confusing. I feel like there's a problem that looked a lot like this last year. Looks sort of like a pain. So let me understand the crashing logic. What I'm most concerned about is okay, that's good. Locations are given in XY coordinates where the furthest left column is X equals 0 and the furthest top row is Y equals 0. So to begin with, I'm going to in this example. So let me just copy this as like the initial one. And what is this called? Minecart madness. Okay. This is going to be a somewhat involved problem. So I hope you've got time. There's probably going to be some person who manages to solve it in 10 minutes. That person is not going to be me, but that's okay. So again, I will do raw, and then I'm going to do, so what I'm going to do is I'm going to do the following. Is first off, from typing import dict set named tuple. I'm not sure I'm going to need all these, but I'll get them anyway. And so what I'm going to say is a track is just going to be a dictionary. And actually, let's do a position is going to be a tuple of int and int. Actually, let me do it this way. Position is going to be a named tuple, and let's see how they call it. They call it furthest left column is X equals 0, furthest top row is Y equals 0. So they call X's and Y's not how I would, but that's fine. X int, Y int. So that's fine. A position is going to be X and Y, and a track is going to be a dictionary from positions to strings, and I'm going to say parse raw is going to be a string, and it's going to return a track. And so what I'm going to do is say lines equals raw dot strip dot split on new line, and so what I'm going to do is going to say for y line in enumerate lines, because they're having y be the column, which is going to be, or y is how far down, which is the first one, and then for x c in let's say enumerate line dot strip, and then what I want to say is I want to say track equals this is an empty dict, and so let's say track the position xy equals c. Okay, so let's say track equals parse raw, and let's just go run this and see if it looks right. IPython run day 13 minecart madness. So if I do track, and as all you can see, I make this same mistake a lot. I construct something and then I don't return it. Okay, so 0, 0, I have that thing. So 0, 0, then sideways. Let's go sideways cart, sideways strip down, then go back to the next row. Sideways that, sideways cart. 4, 0. So oh, this backslash thing is going to kill me, so I need to do that too. Let's try that again. That's good. And then I've got these spaces, and I don't want those spaces either. So if c dot strip, let's do that, and I think that will help. So now with this track, 0, 0, 1, 0, that down, down, 7, 1 is this thing, and then over and across, and pluses and whatnot. Okay, so that's good. Let me do a couple other things. Is that we need a cart. So a cart is a name tuple, and it has a position, which is one of these positions, and I'll just do that. And then a direction, which, and actually, we have this thing where carts move, so turns left the first time, straight the second time, right, and then repeats that. So a cart is going to be stateful, which means we can't actually use a name tuple. So let's not have cart inherit from name tuple. This is where you could use data classes if you're using Python 2.7, but I don't know how to use data classes. So it will take a position and a direction, which is, let me call that a direction, it's not determined. And then a cart always goes left, straight, and right. So let's say self.pause equals pause, self.direction equals direction, and self.next turn equals, and so now I want to import some enums, and I'm going to make enums for some of this. I don't usually use enums in Python, but for today I'm going to use enums and say class a direction which inherits from enum.enum, and I think I'm going to get the syntax right, and I'm just going to say up equals 0, right equals 1, down equals 2, left equals 3. And then I also have a class turn, which is going to be an enum.enum. And a turn is going to be left equals 0, straight equals 1, and right equals 2. So those self.nextTurn and it's going to turn left, then turn.left. And let's say def next turn. Actually, I don't think that's going to work. Def next turn, turn, which is a turn, goes to turn. So if turn equals turn left, return turn straight. Elif turn equals turn dot straight, return turn dot right, and then else return turn dot left. And I think that's what they said. It's always my F keys giving me problems. Turns left, then straight, then right, then repeats those directions, left, straight, and so on. This process is independent of the particular intersection with carts arrived. Carts all move at the same speed. So that's fine. So what I really want to do for parse is I want to return a track and a list of carts. So is this going to be really ugly? This is going to be really ugly, but I'll do it anyway. So parse will turn a tuple of a track and a list of carts. So this will, okay, so let me just do this. If C is blank, continue. Otherwise, if C is that, and let me say carts equals this empty list, carts dot append carts, and it's going to take a position, and I might regret using this position for a cart rather than using X and Y separately, but we'll see. It seems likely I'll regret it. So the cart has the position X and Y, and direction is going to be direction dot right, and track. So let me do pause equals pause XY so that I'm not doing this every time. And track pause equals this. Otherwise, if C is pointing to the left, same thing, but the cart is also pointing to the left. Otherwise, if C equals, and how do we even get those V's and carrots? If C is V, I don't know how to get that. So that is direction down, and track pause equals pipe. And then we have another one, which is if it's the carrots, carts append pause position up, it's a pipe, and then otherwise track pause equals C. So that should be fine, and then return track and carts. So now let me run this and see. Tuple is not defined. That's fine. list is not defined. Okay, should have just imported it all. Okay, so track, so that's not good. And what did I do wrong? What I did wrong was I should have used lowercase pos here, because that's the actual position rather than the class. So let's try this again. Track, so tracks looks right. Carts, and my carts don't look good, but that's because def rep self goes to string. So we want to return f carts of self.pos and self.direction. So that will be better. Do this again, and now if I do carts, I say I have one at 2.0 pointing to the right and one at 9.3 pointing down. Okay. So good. So we've written 70 lines of code to get going. So let's see what the problem is now. Carts all move at the same speed. There are two carts. First, the top cart moves as facing down, so it moves one square. Second cart moves as facing up, so it moves one square. Because all carts move, the first stick ends, and the process repeats. First cart moves down, second cart moves up, blah, blah, blah. So there, and so each of these loops is called a tick. So we need to tell a cart how to take a step. So we want to step self and a track, which is a track, and it is going to return nothing because we're going to modify this guy in place. And an alternate approach would have been to make this thing immutable, and so this is going to have a lot of logic. So we'll say, C equals track self.pos. Okay, so that's so this is the current track type, and so and let me look again at how these crossings work. So he gets here, and then as soon as he gets here, he turns, right? So step and turn. So I guess what I'm going to assume is that he can always move in the direction he's going. So I'm actually not going to do this quite yet. What I'm going to do is I'm going to say x comma y equals self.pos, and if self.direction equals direction dot up, then I'll say self.pos equals pos x, and then we're calling this y minus 1, right? So otherwise, if self direction equal, and it should be double equals direction dot right, self.pos equals pos x plus 1 y. So I think that's right. Otherwise, if self direction equals direction dot down, self.pos equals pos x y plus 1. And then otherwise, it's going to the left. So self.pos equals pos x minus 1 y. So an extra comma there. So that's fine. And so now what I want to do is say C equals track self.pause. So this is the new piece of track. So now we have a bunch of conditions. So if the new piece of track is either vertical or horizontal, nothing can happen. So we just return. Otherwise, if C equals this right turn, basically, so if it's this thing, then we have to be going up, or we have to be going to the left. So and self dot direction equals direction dot up, then we'll just turn. Self dot direction equals direction dot right. Otherwise, if C is that thing and self dot direction equals direction dot left, right? You're going to the left. Then if you're going to the left, you turn down. So self dot direction equals direction dot down, down. Otherwise, if it's this other thing, and I'm going to have to use a raw string for it because it's a backslash, and that's not even working. Do I have to do it like this? I think I have to do it like that, which I hate, but that's fine. So if it's like that, and self.direction is direction.right, then I want to turn down. Self.direction equals, I didn't handle all the cases, right? Let me do this. So if I'm going right, I want to turn up. If I'm going, okay, well, my logic was wrong here. So if self.direction equals direction, so we can actually be coming at this from any of the directions, because it could be a turn like that, and then we turn right. Otherwise, if self.direction equals direction dot right. So if I'm coming at it from the right, and if I'm coming at it from the right, then I'm going to turn up. That feels weird, but I think it's right. Direction dot up. So if I'm coming up, I go right. If I'm coming right, I go up. Otherwise, if I'm going down, I turn left. And finally, otherwise, going left. And so if I'm going left, then I want to turn down. Okay, so that's fine. So that handles that case where it's that turn piece. We also have the other turn piece. And so again, let me just copy all of this and fix the logic. So here, if I'm going up, then I'm going to turn left. And if I'm going right, I'm going to turn down. And if I'm going down, I'm going to turn right. And if I'm going left, I'm going to turn up. Okay, so that's good. And then the only other allowed piece is the plus. And then we'll say else, raise value error bad track C. So that's fine. Okay, so now we need to think about what do we do with this. And at the end, we want to say self.next turn equals next turn. And I'm not going to call this next turn now. I'm going to just call this self.turn. self.turn equals next turn of self.turn. And the question is, do I want to write this out like very painfully, or do I want to find a shortcut? And what I think I want to do is the following. If self.turn equals turn.write, then self.direction equals direction dot direction. I always forget how enums work because I don't use them very much. Direction 1, direction 2, direction 0. Okay, so equals direction of direction equals self.direction.value. Okay, so I'm just going to convert it to an int. So up 0, right 1, down 2. So if self.turn equals turn right, so I want to turn right, so that means I want to add 1 to that direction and then mod it by 4. Direction, I'm going to just call this dir int. Dir int plus 1 mod 4. So it's possible I could have done something like this with the previous turns as well. Otherwise, if self.turn equals, and that's another equals, so if I want to turn left, then if I turn left, I want to, basically if I'm right, I want to go up, so I want to subtract 1 and then mod 4. So self.direction equals direction of dir int minus 1 mod 4. And then if it goes straight, I don't want to do anything. And then self.turn equals next turn self.turn. I think that's good. And so let's run this whole thing and see. Cart equals carts 0. So cart cart.step track cart. So it goes to 3, 0 facing right, cart.step track, and I'll just do print cart like that. 4, 0, and then it's facing down, and then it'll go down, down, and then turn right again. 4, 1, 4, 2, which is here, and it's going to go right, right, straight, and then it'll go all the way to the end and down, and then turn right and come back, and so on. So let me 5, 2, 6, 2, 7, 2, 8, 2, 9, 2, and then it goes down. So 9, 2, and then it goes down, and we think it'll go to 9, 4, and then turn left. Okay, so I think it's doing the right thing. So I feel good about this. And now, what do I want to do is I want to write a function to do a tick. So carts all move at the same speed. They take turns moving a single step at a time. They do this, then the process repeats. Each loop is called a tick. First the top cart moves, then blah, 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 then blah, blah, blah. This ends second last tick. The location of the first crash. So we'll do a tick, and it will return none if there's no crash, and the location if there is a crash. Okay, so let's say def tick, and it's going to take some carts, which is a list of carts, and a track, which is a track. And it is going to return, I'll use optional here. Okay, so it is going to return an optional pause. So, returns none if no crash, location of first crash otherwise. Okay, so how do I want to do this? It says that, so a couple of things. One is that we have to keep track of where all the carts are. So, from collections, import counter. And so, actually, I don't need to do that. I'm just going to do a couple of things. So let's say cart locations is going to be a set. And then I want to move the carts. Carts on the top row move first, and carts on the second row move acting from left to right. So I want to sort them by y coordinate and then by x coordinate. So what I'll do is I'll just say carts.sort key equals lambda cart cart dot pos dot y, is that right? Cart dot pos dot x. So I'm going to find the one with the smallest y coordinate, and then if they're tied, I'll find the one with the smallest x coordinate. And then what I'll do is I'll say cart locations equals cart.pos for cart and carts. So now I have a set of all their locations. Okay. And so for cart in carts, I'm going to do a couple things. I want to say first, let's cart locations dot remove cart dot pos. So I'm assuming that there aren't any intersections at the beginning of the step, which there shouldn't be able to be if we do this. So I remove the locations, and then I want to say cart dot step on the track. Take a step along the track, and then what I want to do is I want to say if cart dot pos, which is its new pos in cart locations, I want to return that location. Otherwise, and then otherwise, I will just cart locations dot add cart position. Okay. So in theory, let me run this again. And so let's say tick carts track, and let's just say print carts. So 3, 0, now blah, 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 blah. They're both moving, 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 they're both moving. And I got a key error. And how could I get a key error? That's interesting. So for cart and carts, print carts. Okay, so print carts, print cart locations. So let me just do that, and then let me print carts. So that's a lot of prints, but we'll see what happens. So run this, and now I don't need to do that because, so that's fine, 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 that's fine. And that time it worked. Why did it work that time? X equals 7, y equals 3. And x equals 7, y equals 3. Okay, so that actually worked. So why did I get in trouble the first time? Well, anyway, I don't know. I must have screwed something up. And so now, let's say first crash equals carts is a list of carts, track is a track, and that's going to return a position, hopefully. And we'll say while true, crash equals tick carts track, and if crash is not none, return crash. So first crash carts track 7-3. Okay, good. So that seems pretty good. Let me copy this day 13 input. Bam. All right. So that's good. So let's say with open data day13.text as f, raw equals f.read. I think I said tracks, track, carts equals, what do I call it, parse? Parse, let me just do this f. Then I don't even need the raw. Track carts equals parse f.read. Print first crash carts, track, and let me make sure I just got the return order right on that parse. Parse track and then carts. So track, carts equals parse. Print first crash. So let us key error pos equals x. So this is the same key error I had before, although this is actually different. So let's look at the track. Let's look at the carts. Okay, so what did I x equals 15, y equals 115. So we can look at that and say day 13.text. So x equals, sorry, y 115, x 15. So let me shrink this down really small. Okay, good. So 115 and 13. So y would, no, that's 14. So 13. Oh, but I wanted 15. So minecart madness. So let me do the following. Oh, that's small. So so when I want to step, I'm just going to print self every time I step, and so I had x equals 15, y equals 116, direction up, and 116. How did I get to x equals 15, y equals 116, direction up? So x equals 15, y equals 116. 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's try and figure out, how did I get to 15, 1, 16? I got there from 15, 1, 17. I got there from 15, 1, 18. So how did I get all these? So here's 118. So you know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 13, 14, 15. So how can I even have been there? Print new track, comma C at self.pause. So let me run it again and see what happens. So this x equals 15, y equals 116, y 17, new track pipe at x 15, y equals 116. So why is that? That seems like I'm not reading the track correctly, because let's so let's look at this track. 0, 1, 2, 3, 4, 5, 6, 7, 8, all the way up to 12. So that's column 20. Are there tabs in? No, there's not tabs in here. It's the, I know what happened. Something bad happened, and that is, I know what went wrong. I did something stupid. And so what I want to do is, I messed up my parse function, basically. So where is the parse? I feel like I made the same mistake last year too. So I don't want to strip. So I want to do what I want to do is, I don't want to do line.strip, because what happens is if I have spaces off at the left, that's going to squeeze it together and mess things up. I want to do rstrip, which is just only going to do spaces off to the right. And so let me add a unit test here. Assert that first crash of carts track equals pause, and I think it was 7.3, right? So let me run it again, and now it works because I didn't do that stupid thing. So 139.65. Okay, that was a really dumb mistake on my part. So 139.65. Submit. That is the right answer. 242 on the leaderboard. Continue to part 2. There's no two different crashes. However, by predicting the crashes, the alpha were to be advanced, instantly remove the 2 crashing carts the moment any crash occurs. They can proceed like this for a while, but eventually they're going to run out of carts. It could be useful to figure out that the last cart that hasn't crashed will end up. For example, after 4 very expensive crashes, a tick ends with only 1 cart remaining. Its final location is 6.4. What is the location of the last cart at the end of the first tick where it is the only cart left? Okay, so now I actually need to change this tick logic slightly. So let me call this tick 2, and it's going to remove crashing carts until only 1 cart is left. and it is not going to return. So, and this isn't even tick. This is last cart standing, call it. And it is going to return a position. So what I want to do is say while true, carts.sort cart locations equals that. And now what I can do is say for cart and carts, and so I'm just going to always check if len cart locations at the end of the first tick where is the only cart left. So I can run the whole tick, I guess. So I don't need to worry about that. So for cart and carts, if cart pos in cart location, for I cart, so let me think. Let me think about the right way to handle this, because I'm modifying this list while I'm iterating over it, which is going to cause me problems unless I'm a little bit careful. So I do my carts sort, and I'm going to destroy my carts. So I'm just going to say carts equals. Although I guess I won't do that. So you know, this is one loop. So I sort the carts like that. And now what I want to do is I want to say so for I carts in enumerate carts. So that's fine. So again, in enumerate carts, and let's say to remove equals or removed equals set for iCart enumerate carts, cart locations remove cart.pause, cart.step on the track. If cart pause in cart locations, then so if I in removed, let's say continue. So if there's something that I've removed, just don't worry about this guy. And now cart locations is a dictionary, so I have to say del cart locations cart.pos. So remove that guy, cart step, and now if this is someone else, then what I want to do is I want to say removed add I, removed add cart locations cart. So I want to remove this guy. I want to remove the other guy at that location, and then I also want to delete cart locations. And I want to delete the other thing. Okay. So I go through, and now what I want to do is I want to say carts equals cart for I cart in enumerate carts if I is not in removed. So let me make sure I've got this right. Move them in this order, and then I want to store a location goes to cart index, and then this is indexes to remove. So if already crashed this tick, skip it. Unregister my location, and then take a step, and then if another cart is at the new location, mark me for removal, mark the other cart here for removal, and then unregister the other cart, and now throw out carts that were marked for removal. For example, so here is a different example. So let's say raw2 is this guy, and then track2 carts2 equals parse raw2, and then print last cart standing of, and I shouldn't have mixed the order up, but carts2 track2. So let's try running that, and that gives me a key error, which is not good. So let's think about this. Where did I get the key error? I got the key error at looking for the track at the new position. X equals 12, Y equals 2. So 2, 3, 4, 5. Yeah, there definitely should not be an X equals 12 anywhere. So track 2 doesn't have anything like that. And carts 2, why does it have an X equals 12, Y equals 2? That's not right. That doesn't even make any sense. And let me just look at raw 2. Yeah, how on earth could he get X equals 12, Y equals 2? So let's look at the logic here that I screwed up. So print pause comma C. So let's run that. And when he's parsing this guy, he gets up to do X equals 4. This doesn't make any sense to me. So it should be slash right that X equals 4, Y equals, why is it this? It's this because it's, is that right? No. How did I do it up here? That seems to have worked. I wonder if it's just the raw thing that I got wrong. No, that still gave me a problem, although it was definitely better. So that looks like the right track. Let me get rid of all these prints because those aren't helping. And so let me try it one more time. So unregister my location. So let's think about this. So while true, print carts, and then print cart locations. And let me try this and see what happens. So I have a bunch of carts, and then a bunch of cart locations. And once I move these guys, oh, I see what I did wrong. Okay. So, otherwise, add me back at new location. Cart locations cart.pause equals I, right? Okay, so I think that will, okay, good. So that seems to be working. And let's get rid of this print. And let's see what other print I have. That's fine. So let's run this. So let us go and say print len carts. Okay, so right. If I forgot to do the stopping condition. So if there's only one cart left, return carts 0 dot pause. Okay. X equals 6, Y equals 4. So let us try this. That's not the right answer. There's some general tips on these about page. So let's just print len carts and carts and see what happens. Well, part of the problem is, I know what the problem is, 6, 4. Okay, so the problem is that I ran it on the test input, not the real input, which is stupid of me. Track carts. Does first crash mess with the carts? I think it does. So let me just reread the data. And then print last cart standing of carts track. So no, I'm just rereading the data because I think I messed with it last time. So now let's, and now I need to get rid of all those print statements again. Print. So let's do this and 4077. Okay. Okay, that is the right answer. 1 gold star closer to fixing the time stream. Rank 239 on the stars leaderboard. You've completed day 13. That was a lot of code. So that's like, 200 lines of code is quite a bit to write just off the top of your head, and it took me like an hour. So but I think it's mostly self-explanatory. So get status, get add data, day 13, get add day 13, get commit mine cart madness, get push. So there was nothing conceptually hard about that problem. There was just a lot of modeling to do, and a lot of things to get wrong. I feel good about the way that I modeled this problem because it's the way that I like to model problems. So, you know, um, here's, I know that I'm going to need to use a position as a key in a dictionary or in a set. So therefore, I need to stick it in a tuple, and if I'm going to stick it in a tuple, I might as well stick it in a name tuple because those are better. Then my track will just be a mapping from positions to strings. Again, you know, the track is this big thing, but it has this really sparse, you know, most of the squares are empty. So doing a sparse representation like this, where we'll just keep track of the locations that have something rather than trying to represent a huge grid, feels like the right way to do it for me. I always feel like it's a little bit artificial to use enums. I almost never use them except for advent of code problems, but I like enums. And so, you know, you have 4 directions. I feel like an enum is a good thing to use there. You have 3 ways to turn. I feel like that's a good way to do it. We could have done immutable carts, but I think mutable was just easier. You know, just tracks where it is, where it's facing, what its next turn is, and then you just had a lot of logic here, and I don't think there's any way around writing out all this logic. We could have written it faster, but yeah. So that's fine. Then this turn logic was actually pretty simple too. So moving the carts around is not too bad. Same with the parsing is not too bad. It's just getting, just gotta write it out explicitly. This tick was not, you know, terrible. There's a little bit of intricacies around managing, okay, what happens when these two are into each other and how do we keep track of that and making sure to do them in the right order, but that wasn't too bad. The first crash was straightforward. You know, I made some stupid mistakes along the way. And this last cart standing, that ended up being a little bit trickier just because we basically have this problem, and this problem isn't good in Python. I'm enumerating over a list of carts, but as I enumerate, you know, as I iterate over it, I want to remove things, and Python doesn't do well with that, so you have to, if you don't want to mess it up, you kind of have to do 2 things. One is, while I'm iterating over the list, if I see like a future element I want to skip, I just add it to a set and then check that I'm not in that set so that I can skip it without trying to delete it from the list while I'm iterating over the list. And then this logic for how do I remove the carts and keep track of this is a little bit intricate, and you can see I got it wrong. Yeah. So, you know, it worked. It just took a bit. So, that's day 13. As always, you can find me on Twitter at Joel Grus. You know, if you want to go look at me arguing with people about Jupyter notebooks and how to write software and whether I know better than my users. Had some good arguments about that today on Twitter. Always be arguing on the Twitters. YouTube, you've found that because you're watching it. And then this Patreon that no one contributes to, just fine. So that's that. And I will be back, I guess, tomorrow. So have a good night or morning or whenever you're watching this, and I will talk to you later.